Mhm. Yeah, thank you. Okay, so today is the first lecture of our course, of our Solidity course, and today I would like to present you Ethereum, probably one of the biggest blockchains right now. So we'll talk about what Ethereum is, some basic concepts of Ethereum, and what this blockchain is all about. If you have any questions, please type them in chat. I will try to answer all of them. And after the lecture, we'll have like a sort of a discussion if you have any questions. Yes, because I might miss during the lecture. Okay. So let's start with several basic questions about Ethereum. The first one, what is Ethereum? Actually, Ethereum is a proof-of-stake blockchain right now, which has more than 5,100 validators. It used to be a proof-of-work blockchain, but in September 2022, it switched into the it switched its consensus to proof-of-stake via the famous The Merge event, which was like an amazing feat for the Ethereum developers. Right now, it is secured by more than 500,000 validators, meaning that there are actually 500,000 nodes running there, producing blocks, validating transactions, and securing the network. Ethereum right now has about 1 million transactions daily, but it is not congested because like market is not that hot. But during bull run events and spikes, this number may rise like 10 times to 10 million daily transactions, and the protocol might feel a bit like costly to use. The main feature of Ethereum, it is its virtual machine. It is the heart of Ethereum. It is what makes Ethereum like possible. It is the idea of the blockchain, and it is the basically program that enables smart contracts to be present, to be executed, and to be understood by the Ethereum. Ethereum also is about Solidity and Viper smart contracts oriented languages, because you can just use the virtual machine on its own. It is really hard because virtual machine runs on a low level opcodes and has its own like structure to the code. It is basically like writing Java programs in a raw bytecode, which is really cumbersome. So to help developers, several smart contract languages were developed, and the most famous is Solidity, and the second most famous is Viper right now. These are high-level languages that are basically compiled to the special bytecode that the virtual machine can understand and execute. Ethereum has a super rich on-chain and off-chain ecosystem. On-chain ecosystem is basically protocols that are already developed and that are already present on-chain, and DeFi, like NFT stuff, these are protocols that are already available to be built on top, to be used, and this enables new protocols to thrive. And because of the rich on-chain ecosystem, Ethereum also possesses an amazing off-chain solutions. For example, there are providers of Ethereum nodes that you can buy and use in your applications. There are third-party like tools, for example, the graph. It is the decentralized tool that enables indexing of blockchain to be used also in your applications, and etc. etc. Ethereum has an amazing community of thousands of researchers and developers. There are a lot of groups, for example, on Telegram, on Reddit, Discord, where people just discuss new topics, maybe some hacks or vulnerabilities in the protocols. And it is an active community that wants to build Ethereum, to make it better, to make it stronger, and it is open to new people pretty much always. Yeah, so there is a question regarding the slide. Is every node has separate Ethereum virtual machine in blockchain? So every node runs like a full copy of the Ethereum virtual machine in order to execute smart contracts, and nodes share information between each other to and they obey the rules of consensus in order to keep the state of the whole blockchain synchronized. So yeah. What are examples of applications of off-chain ecosystem? Yeah, it is, for example, the graph that I already mentioned, and some node providers like Infura or Alchemy or Moralis, if you're about NFTs. How can you run a node in your local? Any steps to follow? Yeah, so you can probably read about Ethereum nodes, like how Go Ethereum has to be run, and follow their guides. It is not that complex. There is a question about Solana. So we won't be covering Solana in this lecture, and actually I'm not professional about Solana, so please ask questions about Ethereum. Okay, so I think that is it about the questions right now. So on the first slide, there was a note that Ethereum is a world computer, and you'll actually find those words together a lot of time, and because yeah, so why is it? Because Ethereum is a huge blockchain. It has a lot of developers, a lot of smart contracts, a lot of nodes. It is highly decentralized, and what is amazing is that it maintains this whole state, and via its really complex proof of stake consensus mechanism. And from computer science perspective, Ethereum is a deterministic but practically unbounded state machine. meaning that in order to change its state, there has to be some action made. And state of Ethereum is basically what this blockchain is at any point of time. It is the current situation on Ethereum. The state includes, for example, Ethereum balances, the state of smart contracts, the variables the smart contracts save in them. It includes the logs the smart contracts emit. It includes the receipts of transactions, and everything is encoded and stored in special data structures. It is deterministic, meaning that there is no random on-chain, and there are no side effects. Every opcode, every step of the program is deterministic, and you can expect the outcome of the execution with 100% determinism. It is practically unbounded, meaning that there is no final state of the state machine. If there is a transaction, the state will change, but it won't ever reach its final state. And the blockchain consists of a globally accessible singleton and a virtual machine that applies changes to the state. Yeah, so the globally accessible singleton state is the current representation of the blockchain, and what applies the changes to the state is the Ethereum virtual machine that you interact with when you're sending transactions. We have a small diagram here. This is our user, which means externally owned account. There are two transactions here. The first one that directly interacts with Ethereum virtual machine, for example, when you're transferring Ether between accounts, when there are no smart contracts involved into the transaction. Using Ethereum, the transaction is interpreted by the virtual machine, which then modifies the state by decreasing the balance of your account by the amount of Ethereum Ether you send, and increasing the amount on the destination account. And also there is a second type which interacts with smart contracts. Then smart contract runs some code that was deployed with, and EVM executes this code and applies changes to whatever the code does. Those changes may be the state of the smart contract or some events, or something like that. Just a second. See the question, how to estimate number of Ethereum states? So there is, I think, no such estimate that's the number of Ethereum states, but I think you can, for example, count how many transactions there are, and this will be the number of states the Ethereum encountered. So smart contracts are kind of listeners for transaction events. Yeah, so you can think of smart contracts as listeners to transactions, because on Ethereum, smart contracts can't execute transactions on their own. They can only reply to the transactions that externally on the account send. And also smart contracts may interact with other smart contracts, but they can't be the initiator of this interaction. They can only like follow what the externally owned account primarily said. Also, if a single transaction happens, does it trigger all the smart contracts in the Ethereum ecosystem, or can a transaction trigger a single or multiple smart contracts based on some payload parameter? No, smart contract transaction actually interacts with smart contract that is present in this transaction. So transaction consists of a lot of fields, and one of the field is 2 parameter. If this 2 parameter is the smart contract, then you can add a special payload that this smart contract would interpret and execute. There is no such thing as like multi-call transactions or transactions inside transactions on Ethereum. So you can only interact with like one smart contract during a single transaction, but this smart contract may do whatever it wants. So you can code like multi-calls inside the smart contract that you interact with. And yeah, it can call like an arbitrary number of contracts unless like the gas is provided. How many transactions one block can hold? It is actually the question from the upcoming lectures, but I will briefly answer it right now. Actually, it highly depends on the transactions because Ethereum may execute arbitrary code. Transactions may become quite large and expensive to run. So every transaction is presented with a special parameter called gas, and like gas limit. And this gas limit says how complex the execution may be until the transaction runs. And if it runs out of the gas, it will revert. And there is a block which has a certain gas limit, and it can accept only transactions up to this limit. So if you have many transactions that are cheap to execute, Ethereum may consume them all. But if you have few transactions with high execution cost and expenses, then Ethereum won't consume as many of them. So it actually depends. But right now, the throughput is like around 15 to 20 transactions per second. Besides deploying smart contracts, what are use cases needed to send transactions directly to EVM? So think of the EVM not as a like something separate from Ethereum. EVM, it is actually a part of Ethereum. So from the user perspective, you won't notice if you interact with like Node or EVM. But the direct interaction is actually when you're sending a transaction that won't interact with the smart contract. So it is the regular transaction of sending Ether and the transaction of deploying smart contract. How to estimate gas amount for transaction? So basically, actually, it is like a topic for discussion, but in Ethereum it is really hard to estimate gas of transactions accurately, because there are a lot of things that were applied to Ethereum during like its lifetime. For example, every call of smart contract from another smart contract consumes one of the 1/64 gas. So only 63/64 gas is provided to the following smart contract execution. And adding this with the gas refund and other hard to estimate stuff, it becomes really hard to estimate the actual cost of transaction without running the transaction itself. So what is done right now, the node actually executes the transaction, but without applying the state. So it's simulates the transaction and outputs the gas required. So that's simple. But with that approach, you can actually DDoS the node by sending a lot of estimate requests. So it is not an easy thing to handle. Okay, I'll answer one more question and we will go on with the lecture. What transaction can hold only transferring amount between accounts or something else as well? No, transaction may hold the Ether that you're transferring between accounts, and it may hold an arbitrary payload that will be presented to the smart contract to decode and interact somehow. And usually this payload is encoded with a special ABI encoding, application binary interface encoding, that the EVM decodes and presents to smart contracts for further interaction. But you can actually send anything there. You can set the destination account as non-smart contract and encode, for example, images and pass them as payloads and use Ethereum as a decentralized storage. But Ethereum is a really expensive decentralized storage, so I not recommend doing this. Okay. So let's define several terms about Ethereum and talk about some basics. Those basics will be used throughout the course, so it is important to understand them right now. First of all, it is the Ether currency. Ethereum is the name of the project of the blockchain, but the currency that is uses to communicate and to send transactions, to pay fees, is called Ether. EVM, Ethereum Virtual Machine, is the heart of Ethereum. We'll be talking about its peculiarities and not how it works on a low level, but how smart contracts interpret, how EVM interpret the bytecode and what smart contracts may do with the EVM. And yeah, it's just the heart that drives Ethereum. Then there is term gas. It is the unit of the transaction's complexity. It is the unit of payment for the transactions. Basically, each transaction has its own gas limit. Yeah, it is that they have already mentioned. And so this gas limit determines how complex the transaction is, and the regular transfer of Ethereum, which is the cheapest transaction you can actually execute, costs 21,000 gas. Gas can be converted to Ether by multiplying the gas limit or like the actual execution gas by the cost of the gas that you provide when you're sending a transaction. If you want your transaction to pass quickly, you will bump up the gas cost. And sometimes it may be quite cheap, like the transfer of Ethereum may cost several cents. And sometimes the transfer may cost several dollars. It depends on the congestion of Ethereum. Yeah, so right now it is like quite cheap. Externally on accounts, it is the off-chain users that interact with the blockchain, interact with smart contracts. It is not necessarily the users like humans. This may be arbitrary servers, arbitrary programs that run on some backend. For example, this may be a program that listens for something to happen in the outside world, in the real world, and pass the outcome to Ethereum. Because Ethereum is an isolated system and it can't just read whatever it wants from the outside world. In order to achieve this, there are several projects, for example, Chainlink, that enables such behavior, but it is a third-party integration. And once again, smart contracts can't initiate transactions. They can only react to the transactions and call other smart contracts inside this huge transaction. And smart contracts are arbitrary on-chain programs. Yeah, smart contracts are nothing more than programs. They can do what they are like coded to do and nothing more. Smart contracts are immutable. If they are deployed, their bytecode can be changed. So the behavior of smart contract may change because it may depend on the storage it uses. It may depend on like other smart contracts that that also depend on storage and other smart contracts. And once the externally on account interacts with any of them, the behavior of your smart contract may also change. But only in ways that are coded by the programmer. And if there are like bugs or something, it is really hard to get rid of them, unless there is special cases for such like behavior, when the as a security mechanism, developers add like special things to, for example, stop the execution of smart contracts and disallow everyone to interact with them and like do something to fix the broken logic. Just let me sum through the questions. How many transactions can Ethereum handle at a given time? It doesn't depend on the number of active nodes. It depends on the congestion of Ethereum. if there are a lot of users and those transactions are heavy, Ethereum will like consume few of them. But if those transactions are light, if everything they do is transfer Ethereum, then it will handle a lot of transactions because the gas limit of the block is 30 million gas, but the cheapest transaction only costs 21,000 gas. So you can divide one on another and calculate how many transactions are like optimistically possible. Ethereum is possible to execute. Gas is constant payment if I deploy smart contracts on chain, or I pay only once when I deploy on chain. No, so what Ethereum does is when you're sending a transaction, you specify the gas limit of this transaction, and Ethereum deducts this gas limit from your account when the execution of the transaction starts. But when the execution completes, it refunds you with the rest of the gas that is left. So for example, you're transferring Ethereum, which only costs 21,000 gas, but you set the gas limit to 50,000. Ethereum won't consume the 29,000 that is left. So it will deduct 50 from your like initial transaction, but then it will refund you the rest what wasn't consumed. And if you're talking about deployment of smart contracts, so it is pretty much the same. You specify the gas limit, it deducts the gas limit from your account, depending on the fees that you provide, the price that you provide. Then it runs the code, the deployment, the constructor of the smart contract does everything that it needs. And after the transaction is executed, it calculates the gas it used, and the rest is refunded to your account. And you have to pay for each transaction, for each smart contract deployment, for each interaction with Ethereum, like interaction in terms of transaction, because reading Ethereum state is free. Writing to state is not free. Does gas price change on blockchain load? Yes, the gas price changes on blockchain loads, and it is basically determined by the blockchain itself, by the Ethereum itself. How? There is a special algorithm that was introduced in the London hard fork like several years ago, and it changed the basic auction model that, for example, Bitcoin uses to something more complex. It introduced the base fee of the block and the tip for the validator. And this base fee increases if the congestion of the blockchain increases. How it tracks that is there is like rule that Ethereum follows, that the block has to be only half loaded, and because the maximum gas limit of the block is 30 million, so the half will be 15 million. If Ethereum sees the blocks that are loaded higher than this 15 million threshold, the base fee will increase due to some like formula that it has. If the Ethereum sees that the load of the block is less than 15 million, then the base price of the block will decrease. And if the congestion is high, if the load is high, Ethereum will see a lot of like full blocks, so the base price will rise, and because it is now more expensive to send transactions, the load will drop. So this is how it maintains the balance. What happens if we run out of gas? Consumed gas will be refunded, or what? If you run out of gas, then you run out of gas. It will consume everything that you provided, and if the transaction saw like enough gas to execute, it will like work as expected. But if the transaction will try to consume more gas that is provided, then revert is going to happen, and the gas won't be refunded, but the transaction will be reverted. Who gets fee or gas? Also, what benefits Ethereum gets from processing transactions? So mainly, fees are burned. This was also introduced in the London hard fork. This base fee that I like spoke a minute ago is actually burned. And due to this concept, Ethereum is a deflationary asset right now. But if you're specifying the tip for the miner, this tip will go to the miner that, like right now, the validator that accepts or builds the block and includes your transaction into the block. And this tip is like purely auction-based thing, like as it was. Yeah. Okay. So let's quickly compare Ethereum to Bitcoin. Ethereum is a proof-of-stake blockchain right now. It used to be a proof-of-work blockchain, but changed its consensus to proof-of-stake. You don't need to mine Ethereum. It is given as rewards for your active participation that you secure and provide trust to Ethereum. Actually, with a current proof-of-stake consensus, it is much easier to lose Ethereum if you're a validator than to earn it. Bitcoin is a proof-of-work blockchain, and you have to spend a lot of electricity to get some Bitcoins, and also to execute like transactions, because to execute transactions, they have to be added to the block, and the block has to be confirmed with the electricity it spends. Ethereum is a deflationary asset because, so yeah, it used to be inflationary really a lot, but right now it is a deflationary asset because it actually burns Ethereum. It burns Ethereum that users provide when they interact with the chain. Yeah, that I mentioned, the base block fee that Ethereum maintains is actually burned and deducted from the overall supply. Bitcoin right now is an inflationary asset, which means that the supply and the number of Bitcoin increases as they are mined, but it is a limited inflationary asset, meaning that at some point of time, there won't be new Bitcoins introduced. They will be they will somehow, so Bitcoin will have to adapt to that somehow, and probably the fees will be given to the miners or something like that. So it won't be inflationary anymore. Ethereum is a Turing-complete blockchain. Ethereum virtual machine is a Turing-complete machine that can execute whatever you want. What I mean by Turing-complete is that it can execute pretty much any programs. You can write whatever you want with that. It is not bounded at no means. Bitcoin has a limited Bitcoin script that is far from being Turing complete. And it is a sort of limitation of Bitcoin because it enables only a certain behavior. Ethereum also enables certain behavior, but at least Ethereum virtual machine can execute whatever is possible to execute. Ethereum is an account-based system because of the virtual machine complexity. It is quite hard to do different accounting stuff and be Turing complete at the same time. And Bitcoin is the UTXO based blockchain. UTXO is the unspent transaction output abbreviation. So what it means here is that in order to send a transaction in Bitcoin, you have to specify the transactions that you are spending. So this enables a lot of cases to be more anonymous and to hide your spendings. But it is harder to implement, and that's why Ethereum uses just a regular accounting system where each account is given a special field balance, and it is really easy to understand how much Ether each account possesses. Ethereum is mostly based around the SHA-3 hash function, which is what's actually used in Ethereum is Keshak 256. It is the minor modification of the SHA-3 function, but for example, the addresses and the transaction hashes, the block hashes are built around this hash function. Bitcoin is based on SHA-2, SHA-156, which is just like that. Ethereum is a rather fast blockchain. It produces blocks per 12 seconds, deterministically. Because Ethereum works under the proof-of-stake consensus, the proof-of-stake consensus requires the block to be added and built every 12 seconds. So no oscillation here. Bitcoin is much slower, and it produces blocks in every 10 minutes, but this can vary if the miners are unlucky to solve the proof of work puzzle. actually, if validators sleep, Ethereum will include the empty block, but still strictly in 12 seconds. Oops. Then there is finality. Ethereum has a guaranteed finality after the 30-second block that is added on top of the current block. Also, this is achieved by the proof-of-stake consensus mechanism. But if like a lot of blocks are added on top of your block, at some point of time, the consensus guarantees a block finality, and there like won't be any chances of altering the blockchain history, because it will require billions or tens of billions of dollars to do, which is impossible. Bitcoin has a probabilistic finality because of the proof of work consensus, but usually the finality is set to like 6 blocks, and after that it is very unlikely for the reorg to happen, but still it is only probabilistic. Ethereum is relatively scalable. It is a bit more agile than Bitcoin. It has an active development community. We know the creator of Ethereum, and like he influences the speed and the decisions that are made in Ethereum really heavily. And probably that is why there are a lot of new stuff that's added to Ethereum, and without Vitalik, this wouldn't be possible. Yeah, and of course they have like huge plans about scalability, about sharding, and stuff like that. Bitcoin is poorly scalable. First of all, because it is like the first one, the Paragon, and yeah, there are like certain attempts to make Bitcoin a bit more scalable. So there are new like opcodes added to the Bitcoin script and some concepts described and implemented, but still it is really, really hard to scale Bitcoin. Ethereum is a tiny bit like better here. Yeah, I'm trying to find some questions. What is 32 block guaranteed finality mean? It means like not digging too deep into the consensus. There are blocks which are called slots, and there are epochs that consist of 32 slots. So basically each epoch consists of 32 blocks. And once the block is added to the chain, at some point of time, the epoch that it is like executed in will be finished, and the new epoch will start. So, and once this epoch is finished, it is considered to be safe. And for each epoch to be validated, every validator has to vote on this epoch, and if 2/3 or more validators accept the epoch's validity, it becomes safe. And once there is a new epoch added on top of this safe epoch, then our epoch becomes finalized and the new epoch becomes safe. So what actually is going on here is that 2/3 of validators voted for our epoch and 2/3 of validators voted for the epoch on top. So we have the intersection of our validators, which is the 1/3. And right now, to become a validator, you have to stake 32 Ethereum. There are 500,000 validators. So 1/3 of that is billions of dollars. And the attacker should gain access to this 1/3 somehow in order to alter the decision of the block, of the epoch, which is like impossible. Yeah, so the 51% attack is still possible, but as Ethereum is like a highly decentralized blockchain, and because it has so many validators, and because Ethereum is not cheap, the consensus was designed with this problem in mind. So it has special parameters and special like course of action it followed when the switch happened, to minimize the risk of such kinds of attacks, which are right now like possible, but super unlikely. You know, it's like a the same likelihood probably of like SHA-3 collision, which may happen but will never happen. In Bitcoin, block generation time is limited by mining. What does Ethereum need some time to create new blocks? Yes, because it needs time in order to synchronize the nodes between each other. It is a highly decentralized blockchain, so it needs to maintain the state. And in order not to place constraints onto the nodes, because they will have to be super powerful and they will have to have a really quick internet connection. And it was just decided to make it like 12 seconds per block, and everyone agreed. Also, the decision was influenced by the proof of work, because during the proof of work, Ethereum produced blocks like in 13.5 seconds. So if they change the time to, for example, 5 seconds, a lot of applications might have broke. But they decided to alter it slightly to 12 seconds, and everything seems to be fine. Where do those 12 seconds go, and why Solana is so many times faster? So Ethereum has an uptime of almost 100%. There were times in its early stage of life when it like stopped producing blocks, but Solana is not like decentralized at all, and we have a famous trilemma: security, decentralization, and speed. So if you need security, you have to be decentralized, and you will lack speed. But if you need speed, then you'll like pull towards the speed. So the decentralization point and the security point will like drop. So Solana has throughput for a lot of transactions, but it sacrifices security and decentralization. And Ethereum, because it holds like so much value in tokens and in Ether itself, it has to be really secure and decentralized. Yeah, so they have just chosen a different path. Okay, then let's just quickly hover through Ethereum ecosystem. I mentioned that it is a really rich on-chain and off-chain ecosystem. Here is the like diagram. It is far from being complete. I think if you wanted to plot every protocol, every project that is right now present on Ethereum, like I don't know if it is even possible. There are so many of them. We have custodial services, infrastructure, exchanges and liquidity, invest in marketplaces, derivatives, stable coins, insurance, and every protocol has like dedicated team of developers, of designers, everything, community, and they all are trying to bring innovation into Ethereum, to build something new, to make the ecosystem better, to adapt more like people, to make Ethereum like mass adopted, etc., etc., etc. Important services that might be referenced in the course are the MetaMask, the wallet that most of Ethereum users use to interact with the blockchain. Actually, what is not present here is the Etherscan. It is the most popular blockchain, Ethereum blockchain scanner. You can search for transactions, search for accounts, search for contracts, blocks, and obtain some information about them. Also, stable coins like DAI, USD coin, they will be referenced in this course. These are like stable coins with different approaches to maintain their peg to US dollar. We won't cover how they like work in detail, but this tokens will be used in several examples. Also, it is worth mentioning the Uniswap protocol, which is the most popular decentralized exchange on Ethereum. Basically, an exchange where you can change tokens, but in a completely decentralized way, which is just an amazing protocol with an amazing community. And worth mentioning OpenSea, which is the biggest NFT marketplace. I think still the biggest, but there is Blur that's right now the like a direct competitive, but there might be some references to OpenSea in the course. So it might like worth looking at the protocol and what it is. Okay, and to finish the lecture, there are several facts about Ethereum I wanted to share. The first one is that Ethereum was conceived by Vitalik Buterin in 2013, but the main development was led by Gavin Wood, who was CDO in 2014, 2015, and then Ethereum was launched on July 30, 2015. So Vitalik Buterin wasn't the main developer of Ethereum. He was the one who imagined and started the discussion of the protocol, but the main developer was Gavin Wood, who right now is working on Polkadot. Ethereum popularized the DeFi because Ethereum is a Turing-complete blockchain. You can code whatever you want there. So the obvious decision was to make money on that. So the decentralized finance was born. And for example, Uniswap is the decentralized exchange, which belongs to the decentralized finance. So there are a lot of like projects that may be used under the term DeFi. Ethereum holds $30 billion of value in smart contracts. These are not the Ether currency. It is the tokens that are built inside the Ethereum. So the ERC20 tokens, NFTs, and etc., etc. And right now the estimate is that those smart contracts that DeFi is worth and holds at around $30 billion. Ethereum is really attractive for hackers, not just the protocol itself, but the DeFi aspect of the Ethereum. Because DeFi is innovation, DeFi is new, it is really hard to implement. It is complex, like every day new protocols emerge that are trying to solve some problems, and usually those solutions are not ideal. There are several bugs in the contracts, and hackers are like sneaking around to find those bugs and to possibly steal something. And Ethereum switched from proof of work to proof of stake on September 15th, 2022, which is as known as the merge. Yeah, such a great feat, actually. It is amazing to see like those updates happen, because basically developers went and upgraded the protocol, like upgraded the consensus of the protocol that is worth more than $30 billion. Like insanity. And why learn Ethereum? So first of all, Ethereum is an innovation. You can decide, you can imagine a protocol like how you want. You can build a protocol how you want. It is completely like open for new stuff. You can become cryptography researcher, which Ethereum is highly dependent on. You can become an on-chain security specialist to prevent the hacks from happening, or to secure the existing protocols, or to secure the not yet existing protocols by providing the experience and like security consulting as an auditor, for example. You can become a DApp developer, writing Solidity or Viper smart contract languages, understanding the EVM and other smart contracts, interacting with the protocols, and etc., etc. You can become a DeFi expert to understand how DeFi works, how to extract value from DeFi, and yeah, just use the protocols and yeah, just become the parts of Ethereum ecosystem. Okay. So let's just check what is in the chat. Where does Binance fit in the diagram? Binance is a centralized exchange, and it should be in the centralized exchanges block. So are there any questions that I missed? What resources would you recommend to start learning Solidity? I'd like to get my hands dirty building something right away. So you can check the Mastering Ethereum book, which I recommend reading for actually every Solidity developer. It is co-authored by Gavin Wood, the CTO. So mostly these books talks about the Ethereum ecosystem, but as of today, it is a bit outdated in terms of Solidity because it was written in 2018. So the examples are like a bit outdated. You can also check the documentation of, for example, Solidity, understand the basic concepts of the smart contracts, understand how, for example, ERC20 tokens work, understand how protocols work, the Uniswap, I don't know, Aave, or anything that you like. Also, you may search for some tutorials or videos online. They will be probably free. And join the community. Try Googling like Ethereum community groups, Discord, or any other social media, and just learn every day. Try to learn every day something new. Any suggestion or outline to become a cryptography researcher on blockchain if we have some background in cryptography? Yeah, so basically the same. So learn new concepts of cryptography, or probably apply to some cryptography researcher roles. And yeah, just try to understand how modern concepts work and like go into that direction.
Okay, the first lecture is always full of questions. Maybe we can finish. And these sets of questions, we will regulate this. So thank you for your attention. Wait for the materials and some presentation. We will add video after processing it. And the names of the book we recommended, let's write in the classroom, I think. Okay. One moment, I turn off.